Okay, so for part 3 then, it asks us to find the value of x that gives the smallest surface area of the cuboid. We'll get the smallest surface area of the cuboid at a stationary point, at a minimum point. So we need to look for when this gradient is equal to 0. So I'm going to set it equal to 0. But rather than writing 32x to the minus 2, I'm going to write this in fractional form. And x to the minus 2 is the same as 1 over x squared. So we've got 4x minus 32 over x squared equals 0. If I now times by x squared to get rid of that fraction, that's going to give me 4x cubed minus 32. This x squared has now gone, equals 0. If I add on 32, that'll give me 4x cubed equals 32. And I can then divide by 4 to get that x cubed needs to equal 8. If we cube root both sides, that gives us x on the left, and the cube root of 8 is 2. So x equals 2 is the only stationary point for this curve. But how do we know it's a minimum point? Well, in order to find if we have a maximum or a minimum point, we need to differentiate the gradient function. We need to find dA squared by d2a by dx squared. So d2a by dx squared, well, we know that dA by dx is 4x minus 32x to the minus 2. So if I differentiate this function now, I'm going to get 4, and I'm going to get plus 64 to the x to the minus 3. Take 1 off again, which is the same as 4 plus 64 over x cubed. So if I substitute x equals 2 into that, we're going to have 4 plus 64 over 2 cubed, which is 4 plus 64 over 8. 64 over 8 is 8, so we've got 4 plus 8, which gives us 12. So that's a positive value, and when we have a positive, that means we've got a minimum point. So we know that when x equals 2, we've got a minimum point. Question wants us to find the value of x, which we've done, which gives the smallest surface area, and we've justified our answer. So x equals 2 is a minimum point, and that's because the gradient, the d2y by dx squared, is positive.